Hi, this is the second part of the graph video. Okay, so here in this particular video, I'll be talking about something called as graph traversal. So we are familiar with the term called as traversal, basically accessing the element. Okay, so here what is meant by graph traversal? Look at the definition. The process of visiting each node of a graph systematically in some order is called as graph traversal. So we are visiting the nodes in some order. We are following some order, and that is called as graph traversal. In that also we have two methods. One is BFS and the other one is DFS. Okay, BFS is breadth first search and DFS is depth first search. So remember, in case of BFS, we make use of a data structure called as queue, whereas in DFS, we make use of a data structure called as a stack. Okay, so remember the concepts of queue and stack before we start this particular discussion. Okay, try to recall all the things, the insertion, deletion happens at which end, all this you have to remember. Okay, so we'll start with the first one, that is BFS. Okay, what we do is, the idea of BFS is, you start at any of the nodes. Okay, you start at any of the nodes, and then from there you try to find out its neighbors. You start at a node, find out its neighbors, make a list of it, and from those neighbors now you choose any one node and make its neighbors. Like this you go on making the list. Okay, so here you see how I have solved this problem. So here we have 6 nodes. Okay, not 6, 7, sorry. Okay, so A, B, C, D, E, F, G. Okay, when we are giving you a problem like traverse using BFS or DFS, this is the method that you have to follow. You have to write this table. As you can see, it has 4 columns. Okay, so one is, I told you that it makes use of the concept called as queue. So we need to have one column for the queue itself, for writing the contents of the queue. So here it is shown. Also, if you remember during the lab program, I had told you that each node has to be visited only once. But how do we make sure that? For that we have one more column called as visited. Here we keep track of the nodes that have already been visited. And once you choose a node, you also have to choose its neighbors. So here that is one for the keeping track of its neighbors of a given node. Also, we have one more column for queue. Because we are making use of queue, here we also sometimes have to pop out the elements. Okay, I'll talk about why we have to pop out the elements and all of that. Okay, so initially we start at the node, find out its neighbors, and from there we proceed. So what I have done is, I have chosen A as the initial node. So you can choose any node as your starting node. I have chosen A. So initial value, okay. So delete is nothing, adjacent is also nothing. See, I have chosen A, so A will go into the queue. Okay, once it goes into the queue, you know that it has been visited. So the visited column is also updated to A. Okay, now once you have that element A, okay, check out its neighbors. So adjacent nodes. So for A we have B, D, E and C. These are the adjacent nodes of A. So we write, see here, B, C, D and E. We have made the list of its adjacents. Now A is already visited here. So we will make a list of the other nodes that we have visited. So A is visited, B, C, D and E. Once you do that, okay, pop out the element that was last inserted. So here A was last inserted, so that will get deleted here. So whatever remaining elements are there, that will remain in the queue. Now you have these nodes, okay. Now you can choose either B, C, D or E. So I have chosen B. I have chosen B. So B will come out of the queue. Now for B you find out its neighbors. For B you find out its neighbors. Its neighbors are A, D and F. Okay, for B the neighbors are A, D and F. So A, B, C, D, E is already present in the visited. F is a new one, so I am adding that also to the visited list. So A, B, C, D, E, F. Okay. So once we have identified the main vertex, it will get deleted from the queue, right? So now the elements present here are C, D, E and F. Okay. Next, out of these 4 elements, choose any one of them. So we have chosen C. Okay. Now we have chosen C, this one. Check out its neighbors. Its neighbors are A and G. I hope you are following. You also please look at the diagram. Okay. So when we are having C, its neighbors are A and G. So A and G. So visited will be now updated with the element G. Once we have done that, C will get popped out because that we have taken as a main node now, and the elements left will be D, E, F and G. Okay. So whatever we have last inserted, if it is not visited, that will get into the queue. Now we can take any one of the element from this particular list, D, E, F, G. So I have taken D. Identify its neighbors. Okay, if it is already visited, put all those elements. Then pop out that element that you were taking into consideration in the first case. So here we have removed it. Okay, now you come back. So E. E is A and its neighbors are A and J. Now remove that. So F and J will be present. Okay. Likewise, now F, its neighbors B and D. Visited is already done. So F will get popped out. G will be left. Now G will be into your deleted list. Its neighbors. So this will be the nodes visited. So now all the elements have got popped out. So it is left with nothing. So this is how we get this will be the nodes that is reachable from the given vertex. Here in this case the vertex is A, the source. Okay. So the idea is you take one of the nodes, okay, make it as visited. From there you consider its neighbors. Once you have the neighbors, delete this element from the queue. Put it into the queue initially. Now delete it out. Now you have the neighbors, right? So from there you choose any one of the nodes as a main. Okay. Now you choose that one. Then choose its neighbors. Okay. Check if it is visited. Okay. Remove that element. Put the other elements into the queue. Likewise, you will go on doing this till all the elements of the queue are popped out and you are left with all the elements that have been visited. That becomes your answer. Okay. So the second method, that is DFS. This makes use of a stack. Remember, this makes use of a stack. The idea is here also you consider one vertex to be the source. You start from there. Identify its neighbors. Okay, like how we did for BFS, here also identify the neighbors. In case of BFS, what we did is once we have identified the neighbors, we make use of, we keep a track. So we used to put everything into the queue, right? So here what we do is, we choose the neighbors. Okay, we have the list of neighbors. You choose one of them for traversal at a given point of time. In case of BFS, we took all the elements into consideration. Whereas in case of DFS, you take one element at a time. See here, I'll explain this with an example. See, we here need these 4 columns, okay? We need one for stack, like how we have there for queue, we have that. Then we have adjacents, the visited list, and one for removing the elements. See, initially, I put A into the stack. I'm considering that as a source vertex. So, initially, it will not have anything. Keep it like that. Okay, so the node visited is A. Next, check out its neighbors. Okay, so A is having the neighbors B, D, E and C. Now, instead of writing all the elements, we choose any one. So, I have chosen B. Okay, so now if I have chosen B, that means I have visited that particular node. So A and B will be going to the visited list. Okay, now the stack will be filled with A and B. Now you take the next one. Okay, from B. Okay, from B, check out its neighbors from B. So from B we have D or F. So you can go from B, you can go either to D or you can go to F. So I have chosen D. So once you do that, A, B, D will be into your visited list. That only will be in your stack. Okay. Then from D you take an element that is adjacent to it. So from D we have F. So I have written A, B, D and F. Okay. See here. A, B, D and F. Now from F you have to choose the next element from F. See, from F the adjacent one are B, the other one is D. But the thing is you can't write this into the adjacent list because this is already visited, right? So you can't write it. So we will write adjacents as empty. But the thing is, okay, if F can't be traversed, if F is not used because the adjacent elements are already visited, right? Now what we do is we pop out this F. We pop out this F. Now the control will come to the remaining elements exactly to the point D because last in, right? So this one A, B, D. So from D you check now. From D we can either go to F. From D we can either go to B or we can go to A. Okay. But if you see those elements are already visited. Now what do? You again pop out the element. You pop out the element. Okay. So D also will get popped out. So you're only left with A and B. So A and B you will check, okay. So for B you will check the adjacency. So we have for B the adjacent elements are F, D and A. F, D and A. But they are already visited. So what do? You pop out the B also. You will be only left with A. So from A again you do the traversal. From A we can go to E, we can go to C or we can go to, let me erase this first, okay. Let me erase this first. 1 minute. I'll erase this. Okay. See, from A. We are here right now. A. So check the unique one that we have not visited. If it is present, C is not visited till now. So that becomes the next one. So A, B, D, F and C. Okay. So visited list is having that. So A and C, other elements are already popped out. B, D and F is already popped out. So we are only left with A and C. Now for C, you check if there is any adjacent one. For C there is. What is that? G. Okay, because A is already visited. So G. So that will go into the visited list. Okay. Next A, C and G. Check out its adjacent, that is E. That will get added to the adjacency list. Okay. Visited list. Likewise, you go on doing till all the elements of the stack are popped out. And whatever we have here will be the final result. Okay. So take some question. We have a question here. Okay. After you are done listening to this, okay, go back, check the notes, check the video, solve this particular question. If you can, send me the answer. You choose any one of the questions and for that you can do the BFS and DFS. Remember, see, for BFS and DFS both, you can visit any of the nodes, right? You will make a list of it. From there, when you proceed, you choose any one of them, right? So the idea is sometimes you might choose one node, I might choose one node. So there is no one definite answer for this type of questions, okay? It totally depends upon the nodes that you visit. Remember this, okay? So practice the questions like this. Next topic is about the lab program. So we have already spoken about the lab program. So recall the program and real life applications are there. See the applications of BFS and DFS. BFS is used for the very very important and very popular kind of application, that is finding the shortest path from a vertex to another vertex. It is also used in peer-to-peer networks, social network websites. It is also used in GPS navigation systems. Also DFS, okay, topological sorting to find the connected graphs, to find to produce a minimum spanning tree and shortest path tree, and also to detect cycles. Okay, remember in case of BFS we make use of cube and we start at a vertex and note down all its members. Once you have noted down all the members, from where you have started, that node you pop up, and from that list you choose any one of them and proceed like that. Whereas in case of DFS, again start from a given node, okay, identify its neighbors, but then take only one at a time. Are you understanding? I hope you have understood. So go through the notes also, and example is also there. Try to solve it and send me the solution. Okay. Thank you so much.